Hey everybody, and welcome to the cell cycle, or what cells do with their time. What a cell does from its sort of birth, or when it comes into existence, to the time it gives birth, or... Hey everybody, and welcome to the cell cycle, a day in the life of the cell. We're going to go through an animation at the end, but I want to kind of walk you through a PowerPoint and an analogy to get you started, understanding what it is cells do. So to begin with, cells have to divide, right? Whether you're talking about this little guy to the right, my son, who was born about a week ago, or this little axolotl here, looks like it was hatched out about the same time, or maybe a little bit more recently. They have inside them lots of cells. These guys both started out, believe it or not, as single cells. And since then, they've gotten more and more cells. And since they're youngsters, they'll both continue to get more and more cells as they go. So how does this happen? How does something go from one cell to two to four and so on? Well, I think one of the best ways to talk about this is through an analogy of a football game. So excuse me for the analogy for a second. You know I do this sometimes, and I apologize. So imagine a week in the life of a football player. Obviously, the big thing, the thing everybody's focused on is the game. And it happens sometime Friday night, right? That's super important to any football player. It's obviously the reason for everything that they do, but it's not the only thing that happens. Football is sort of unique in that there's always a game at the end of the week, and you spend the whole week either processing or prepping for the next game. So if you take a look at this week calendar here, imagine us kind of starting right after the game. And if we start after the game, you can imagine the next couple of days being all about rest and recovery. You just got done playing the game. Maybe you take your ice baths. You do a lot of stretching. You hang out with your family. You think about the game a little bit, but mostly it's rest and recovery. Then you come back to school. And when you come back to school, maybe you look at some game film. You have practice in the afternoon. Usually you'll reflect on that previous game, see what you did right, see what you did wrong. And then in that practice, maybe try to fix some of your mistakes. As you keep going, you're still going to go to class. You'll have weights. You'll go back to practice. You'll do a few other things as you kind of get through your daily routine throughout the rest of your week. And then as you get closer to the game, maybe your film study kind of shifts from focusing on the old team to focusing on the team you're about to play. You focus on them. You get yourself ready. You're continuing to do all of the other stuff like practice and classes and eating and so on. And then as you lead up to the game, you prep for the game. You talk about what you need to do in that game. You eat right. You get out on the field. You get ready to go, stretch, do your warm-ups, and then the game starts. And then you go through the same cycle again. And this is how the cycle works, right? We go through this week after week. But realize, too, we're not always in football season. Sometime it's not, right? And football players are still football players even when football season isn't happening. And they tend to go through this sort of little cycle here, which we'll call our off-season cycle, where, yeah, they're doing weights, they're getting stronger, they're conditioning, they're going to class, getting bigger, maybe watching more film a little bit here and there. But again, it's not the same as a prep week. They're kind of in this holding pattern, waiting for the season to start again, and then they go back into the normal cycle, prepping for a game. Well, our cells do something really similar. The goal of a cell isn't a game, it's division. Cells want to, again, like we've said many a time, make copies of themselves. Once a cell makes a copy of itself, then those cells can do the same and so on. Inside both my son and inside our axolotls, cells are copying themselves right now. So how does this happen? Well, the process of copying yourself is called mitosis if you're a cell. To go from one cell to two, that's mitosis. And that's actually going to be our next lesson. We're going to talk about the game of mitosis, if you will, next lesson. But what we're going to talk about today is the rest of the week. What are cells doing during the time as they get ready for mitosis? Everything but the game itself. So remember, before you can make a copy of yourself, you need to make a copy of the plan. Both of the new cells need to have the plan or the DNA present in order to make copies of themselves eventually. That DNA is going to tell them how to build all of the parts inside them, and you have to have the DNA in every new cell. So before you can go through copying the parts, you have to copy the plan. And of course, the process of copying that plan, located in the nucleus there, made of chromosomes, is called DNA replication. We learned about that a few weeks ago. So before a cell can make a copy of itself, it has to copy its DNA through DNA replication. So each new cell is going to have its own copy of DNA. This can be a little confusing in terms of the names, so let me go through this a little bit. So a question you might ask yourself is, how much information do we have inside each of our cells? Well, believe it or not, you have almost 2 complete sets of information for how to build a human inside you. Not just 1, but 2 sets of instructions. Why do you have 2? Well, you have a set of instructions that mom gave you, and you have a set of instructions that dad gave you. We'll talk next unit when we're doing genetics about how you know which set of instructions to listen to, but we essentially have 2 complete sets of instructions to build a human inside us. We call the amount of information necessary to make a living thing N. We use that uppercase N to represent all the information to make one living thing. But like I said, inside us, we have double that information. In other words, every normal cell inside our bodies have 2N. They have 2 sets of every chromosome, and they have, again, information from mom and dad. So the normal cell, nearly every cell in your body, has 2N information in it. So what's another way of thinking of this? Well, again, nearly all humans have 23 pairs of chromosomes, minus some people with Down syndrome and so on. So nearly all people have 23 pairs, and here they are. They're numbered 1 through 22, from longest down to shortest. And again, you can see they're normally listed in pairs. Again, in principle, 1 from mom and 1 from dad. And if you look down here at the bottom, there's this weird X and Y. Those determine our gender, and we're going to talk about those a little bit later. But if you have 2 X's, you're female. If you have an X and a Y, you're male. We'll get to that stuff later. So another way of saying this, right? For humans, N is 23 and 2N is 46. If you counted all the chromosomes here, you'd count 46, or 23 pairs of chromosomes. But again, 2N, 46 chromosomes, or 23 pairs. Now, in order to make a copy of a cell, though, and this is where it gets even more confusing, we actually have to double up that 2N, because every single new cell also has to have 2N once it starts, or when it's created. So we go from a 2N cell like this, normal everyday cell, DNA replication happens, and all of that DNA gets doubled up. So our cell goes to a 4N cell. Now it has enough information, double the information, that it can eventually split via mitosis and make 2 2N cells. So again, 2N goes to 4N, and then back to 2 2N cells. And this is how we get from just 1 to 2 cells. Okay, so that aside, let's talk about everything that has to happen for this whole thing to go on. Once again, in a cell, the goal is to make a copy of itself. The game, if you will, is mitosis. Mitosis is what everything is headed in the direction of. But we still have an entire cycle to go through to get us to the place where we're ready to do mitosis, just like a football player has to go through a week of preparation before he or she plays a game. So how does it work? Well, imagine a cell just after mitosis. We've got a tiny little baby cell, and this cell here has just been the result of mitosis. So it's right after a game or right before we start our new cycle. So what does this little guy have to do to get ready to divide? Well, number 1, it needs to do some of the stuff that cells do other than copying themselves. He needs to get all of the proteins together to build his body and to build himself up. He has all that information. He needs to build all of his organelles. He needs to build any proteins that he needs to ship off to other parts of the body if he's in a multicellular organism. And much of this happens in what we call the G1 phase, or the gap 1 phase. So after mitosis, again, this is sort of like going to class, studying, lifting weights. The cell is making proteins via protein synthesis, or transcription and translation, which we talked about a few weeks ago. But it goes through this process for a while, continuing to grow, continuing to build up its parts using protein synthesis. Now, if it gets to this little checkpoint here, and it realizes that it's not big enough, it didn't have enough energy to build up enough parts, if it didn't get to the place where it can start thinking about doubling itself, it kind of goes into this off-season or G0 cycle. That G0 cycle can last for a long time. If you're a tree in the winter or something and you're not getting enough sunlight to grow and you've shut your body down, maybe you would sit there in this G0 phase all winter long before you get the energy from the sun to start your process again. Maybe you're a hibernating mouse and you aren't getting any energy because you've buried yourself down in the ground and you're just not doing anything for a few months. Again, probably your cells are in the G0 phase. They're not growing and dividing. As an older person, many of my cells are in the G0 phase because I'm not consistently growing and making new cells. But if your cell has enough energy, it's got enough juice at this checkpoint, then it will move on and start the process of getting ready for the game. So it'll sort of leave the off season and start prep for the actual process of mitosis. So when it does this, the first thing it has to do is synthesize or copy its DNA. So what it will do is it'll start that process of DNA replication. As DNA replication happens, that 2N goes to 4N, and the cell doubles up its information. Once it has double the information, it's now ready to undergo mitosis as long as it's big enough and ready to go. Before it does that, though, it'll generally go through what we call the G2 phase. The G2 phase is more practice and weights and classes and eating. It's more making proteins, more getting itself ready, and more building itself up. Once it's done with the G2 phase, there's another checkpoint, and if when it meets this checkpoint, it is big enough, it'll undergo the process of mitosis, splitting from one 4N cell into two 2N cells. And that's it. That's the cell cycle, beginning and or ending with mitosis. Technically, when we talk about the cell cycle, everything except for mitosis is what we call interphase. It's a cell in its normal phases of life. When we actually talk about mitosis, you'll hear that phrase interphase again. But technically, interphase is everything but mitosis. So it's all of the game prep and everything other than the game itself. And that's pretty much it. That's a cell cycle. That's how it works. That's how cells go throughout their daily lives of getting ready to make copies of themselves. This tutorial here is great. It says the same stuff, but it goes through it in a little bit more of an animation here. So I'm going to hit the play button here. Notice we're starting just where we did, right after mitosis. And you'll notice our cell here has 2N information. We play it, and it goes through that G1 phase. In this G1 phase, again, what it was doing is building proteins, doing its normal cell processes. If you forgot that, you can click over here, and it'll tell you what it does in that G1 phase. From here, it gets to this checkpoint, and if it has enough information, it enters the S phase. And you'll notice in that S phase, it went from 2N to 4N. As it goes through the S phase, it continues into the G2. In the G2 phase, there's yet another checkpoint to see if it's ready. Has the DNA copied itself? Is the cell big enough? Is the environment suitable? If everything's ready to go, then mitosis happens. There's a quick checkpoint inside mitosis. Don't worry so much about that. It's beyond our scope. But once it does it, it goes through the process of mitosis, and the end result is 2N cells. One more time, just to rewind it so you can see it. Starting at the beginning, G1 phase. It'll go in that G0 if it doesn't have enough energy. Otherwise, it continues, enters the S phase where 2N goes to 4N. Once 2N goes to 4N, it continues to make proteins, doing all it needs to. One more checkpoint. If it's ready, it divides, and we end up with 2 cells that are 2N, ready to do the same process. And that is the cell cycle. Join us later for a discussion of mitosis.